So good afternoon all. So am I audible?
Yes, sir.
Yeah, okay. So we will wait for a couple of more minutes so that once other participants join, then we can start. So good afternoon all. I think we can start the session. So today we have listened to Professor Lok, as well as Dr. Professor Dubey, on the stability of the nanoparticles with respect to Professor Lok in the morning, and then the introduction, and then why life cycle assessment is needed, and then where it is being used extensively by Professor Dubey. I think those two lectures would help us in one aspect of how the nanoparticles behave in water, especially the colloidal stability, the chemistry behind it, and then the parameters that we need to check, and then how these nanoparticles keeps imparting toxicity towards the microorganisms. Am I audible? First of all, yeah, I think so. Am I audible? Anyone can confirm in chat box.
Yes, sir.
Yeah. Okay. Fine. Moving on, in the second lecture, we had the life cycle assessment by Professor Dubey, and then in continuation with that, today we will be looking ahead the same thing, but in a different aspect of how this life cycle assessment or a tutorial on life cycle assessment or analysis, you say it, and then what are the parameters that we need to think upon, and then how it is related to nanoparticles and as such. So here, when you look at the course structure, it has been decided. Actually, this course was supposed to be there in the physical mode, and then the main motto was to have a hands-on session with you all. But still, we tried upon installing the software and then everything, but it was not that easy to communicate with respect to the online mode. So we found it difficult, and then today I will be splitting these 2 hours into 2 sections. In one section, I will be just taking you for... Yes, pardon. Something. Stop share. If you have anything, you can drop down in the chat box, and then I'm muting you all. Thank you. Yes. Yeah. So I think that was the main motto of having LCA study for this course. But I still, as I was mentioning that, we will be having 2 different sections for this course. One will be taking down with respect to the theoretical aspect, and then one I will be demonstrating with respect to the software. And then at NIT Andhra Pradesh, we have a licensed version. So I will be showcasing you how to carry on a life cycle assessment analysis. Before we will be looking the same with respect to the help of screenshot, and then again in the later second half we will be, or otherwise I'll be taking you down through the line of the software of how to do a life cycle analysis. It's simple, pretty simple. I think from the morning class itself you would be able to understand the basics of it, but still I will be taking you through it. And then there will be a slight change as discussed. There in the curriculum, it has been mentioned that life cycle analysis study of silver and cobalt oxide nanoparticles will be discussed, but for a slight change, for a better understanding, as everyone is not from the same domain, we have just changed the case study as LC of PET bottle. That is nothing but the polyethylene terephthalate bottle that we consume for each and every day item. So so moving on. So life cycle thinking. So one such thing is that, so how we keep the whole prospect or the aspect towards the product. So be it from the raw materials, extraction of raw materials, and then the materials, how it is being manufactured. And then from the materials, there would be different materials that could go for a single product. And then here comes the product manufacturing. When it comes to product manufacturing, one is the transport that comes along with the materials, as well as the energy that goes in for the product, the waste in which it gets generated, So all the aspects would be coming. With respect to materials, again, the raw material extraction, transportation, and refining is one such thing that comes in material manufacturing. Once the product gets manufactured, again, it is transported. Now I think you can able to do. Yeah. With respect to the distribution of the product, say assume that it can be a PET bottle, the raw materials from the crude oil section, the materials, again, it has been refined, the product is being manufactured in terms of small pellets, and then with respect to molding, the bottles have been made, distributed. Before distribution, again, the empty bottles have been distributed, or else the bottle has been filled with a specific liquid, be it the water, be it the tonic, be it the liquor items. So different things can be filled in, and then it can be distributed. And then it comes to the circulation mode. So here comes the circulation aspect, which enters the market. And then once it enters the market, it has been used by the consumer. So when it comes to use, so this is up to the consumer use, and then thereafter comes the post consumer use. So either the water can be discarded or at a specific place, or else it can be discarded as such all along with the other materials. And then from that, whatever that can be retrieved, so it can be reused or recycled. In Indian case, some of the PET bottles have been reused to a certain extent, and then recycled to a certain extent, not to the maximum extent, and then at last the final disposal. So as of now, the one such example is that these PET bottles have been recycled in one or the other form in Indian case by an informal sector, not by a formal sector. Especially the examples that we can have, a live example is that once the arrival at any point of junction or a major junction, all the rack pickers, kabadi walas will collect the plastic bottles. They will remove the cap, they will remove the wrapper, and then they will have only the bottles, and then they earn the money out of for their livelihood from those bottles. So here the recycling aspect comes, and then reuse is the reuse and recycling aspect where it differs is that without much of energy addition, we keep going for reuse. And then much of energy addition, transportation, cleaning, and then everything, the material gets deformed from its original position. We call it as a recycling. So one or the other form. So even the PET bottles are being recycled to a t-shirt or a fiber, or else with respect to shoes, everything that can be recycled. But in the reuse, the bottle that we collected, we store water and then keep drinking for normal 1 to 2 days or 3 days or for 6 months or 7 months. But most of the times, whenever we buy a water bottle from the counter, it has been advised to crush the water bottle once after its use. But still, in Indian case, conservative society, so that makes us to keep using the bottle again and again. So life cycle assessment, it all comes with the standard ISO, whatever the standard, whatever the study that you pick up, it mainly depends upon the standard ISO 14040 and 44. So mostly these two standards will be reflected in most of the cases. So when it comes, so as the same pictures have been given in the different form. So this section gives us what are the steps that needs to be followed with respect to the life cycle analysis. Mostly the goal and scope, the inventory, as well as the assessment, and then as well as the interpretation part. So these all define those. And then with respect to 40 series standard, life cycle assessment addresses the quantitative assessment methods for the assessment of environmental aspect of a product or a system in place, and then which serves its entire life cycle stages, be it the raw material manufacturing, product manufacturing, distribution, consumer usage, and everything. So ISO 1440 is a standard which comprises of all the 4 stages. That's what as I mentioned, be the goal and scope, inventory analysis, assessment, impact assessment, as well as the interpretation. So life cycle is a holistic environment assessment tool for sustainability assessment and strategy at product level. So this is one such thing that also gives us the impact of a product onto the system, as well as tells us which is the most sensitive part, so that we can keep thinking some green pathways so that the impact can be reduced to a certain extent. So covers value chain of products, upstream raw materials, transport, manufacturing, downstream, that is nothing but the transport, use, and disposal. So it takes care, as it gives a section by section details with respect to the impact of these onto the environment, it can be assessed, and then the interpretation can be done in such a way that the assessment can, or otherwise the impact can be reduced to a certain extent. So when it comes to impact assessment, mostly the environmental parameters have been used to communicate to the society. So we will be looking at those environmental impact categories in the down the slide. So moving on. Phases of life cycle. There are three different terminologies. If you pick up any of the journals, they would have said that cradle to grave. So cradle is nothing but the beginning of the product to the grave of that product. See, assume that from the raw material extraction till the product gets to its deathbed. That means that the product has been thrown, consumer is being used, or the product has been used a number of times, and then it has been thrown out to a landfill or a dump yard. So mostly in India, we call it as the dump yard, or still the segregation of solid waste has not been done to a maximum extent, and then reuse or recycling is not to the optimum level, but still it has been thrown out to the environment. Then cradle to gate is one such definition that has been used. There's nothing but cradle. So once the birth of or the raw material extracted to the gate, the product in which it's getting manufactured, nothing is looked in detail with respect to how the product, or otherwise the product behaves in the consumer market, post-consumer or pre-consumer use. Gate to gate is nothing but only the production. So that is even the raw material extraction is being removed. So once the product comes as a refined thing to a campus, and then once the product goes out, or otherwise it gets as a product, so that is being only considered is nothing but the gate to gate. So within the gate, what happens for a product, and then how much impact that it has onto the environment. So be it water, be it soil, and then be it the air. So life cycle stages, as I mentioned, that it is nothing but the production stage, use stage, and end of life. So end of life, it can be disposal, recycling, or deposition. So this we will be again looking into. Moving on. So what are the things when it comes to phases of life cycle with respect to the production stage? The main thing that is needed for a product to get manufactured is nothing but the energy that goes in, the materials that goes in, as well as the natural resources apart from the energy. So mostly water that goes in for a product to get it manufactured. So normally these three are the inevitable substances that goes in. Apart from that, transportation is one such thing that is being added to transport a good from one place to other place. That also has a severe impact. That though it is not being considered to a greater extent, but still transportation either through road or through rail or through water has a severe impact onto the. It adds value to the impact, or otherwise it has its specific set of weightage when it comes to the environmental impact onto the environment. So with respect to impact assessment, how do we assess the impact in which a project has been manufactured and then onto the environment? So as it goes, the inputs are nothing but the resources that goes in for a product. So what kind of resources, be it the natural resources or man-made resources, how much it goes, the quantity, and then how much the product is being manufactured. Assume that if you add 10 kilos of A substance A, 10 kilos of substance B, and 10 kilos of substance C, and then at last you get a product of say 30 kilograms or otherwise 25 kilograms. So all the unit impact will be there with respect to the 25 kilogram of substance or the product that has been manufactured. Otherwise, this in softwares now there are a leniency with respect to how these are being can be extrapolated to even 1 kilogram of material that has been manufactured. And then when it comes to the output, that is nothing but the emission and waste. So how the waste, because of the manufacturing process, what kind of waste, what kind of emission, what kind of heat that is being liberated out, that also comes as an output. So most of the time, the boiling water, or otherwise the steam that comes out, or steam, mostly the steam is used for again recirculation into the process. Again, there it becomes a resource, but again the emission and wastewater is one such thing that needs to be looked at. What is the quantity of emission? But still, in order to arrive at what would be the quantity of emission for 1 kilogram of material produced or 1 ton of material produced is still very minutely to be worked out. But still, if we could able to get those values, then it would be really good. way of doing. So it is more or less mimicking the real-time scenario and then assessing the values. So what kind of assessment that can be done? So the impact on the greenhouse effect. So mostly the greenhouse gases, how much it is being emitted. Smog, again, it also reflects to the air pollution, and then acidification potential. Then again, whatever the impact that comes around with respect to the soil, acidification potential, eutrophication potential, water depletion, and fossil fuel depletion, and then everything that comes out with respect to the soil. So these are the impact categories. It differs with respect to the software that it is being put in use. Normally, LCA can also be done with respect to some of the open source software, but all depends upon the data that where you get it from. So we will be also looking at the standard databases or the software that have its own database. Before going into that, these are the impact categories, or otherwise terminologies that is used to communicate the results efficiently to the audience. So one is global warming potential, again, how much of amount of carbon dioxide or methane is being let out into the atmosphere so that the earth gets warmer and warmer. Acidification potential, the gases that is being released. Eutrophication potential, the amount of nutrient that is being dumped onto the environment because of its manufacturing. Ozone depletion, stratospheric and tropospheric. Now, smog potential, again, the particulate matter or with the ozone formation. Toxicity, the carcinogens that is being emitted onto the atmosphere is nothing but the toxicity. Resource depletion with respect to water depletion, fossil fuel depletion, be it the carbon source. Where does the carbon source come from? Be it the hydrocarbons or otherwise the carbon that is used for generating electricity. Land use and transformation, how the land use has been taken into consideration. Assume that there is a cement plant, and then once there is or otherwise a thermal power plant, when once you burn the ash, and then you will be having a lot much of hot water that comes out all along with the fly ash. How the land use and its change impacts onto the environment. Primary energy demand, where does the energy comes from? Whether it is from a renewable energy source or otherwise a non-renewable energy source. Even if you have looked into that, every country is moving towards moving towards from coal to green energy. There is a shift, and then each and every, even 2 days back, that by 2050 the first city to go neutral or otherwise carbon neutral is nothing but Bombay has taken the pledge, and then India is hoping its level best to be there by 2030 50 or 70 or so, but the deadline is 2070 as per the sustainable development goals. But still, in order to do that, these are some of the sustainability tools that will help us to assess and then look for alternatives so that we can achieve the goal. And particulate matter emission, that is also being communicated, what would be the concentration of those particles which will be there out in the environment. So again, less than 2.5. So among these, global warming potential and primary energy demand and water depletion, because energy is one such thing that needs to be mined, transported, used for power generation, and then as far as primary global warming potential, the amount of carbon dioxide as well as the methane being let out into the atmosphere, and water depletion, because water is needed for each and every sector, be it the coal-fired power plants or otherwise the nuclear power plants, and whatnot. Every semiconductor industry which uses more and more amount of good quality water. So most of the semiconductor manufacturing countries are facing these issues. So how to cope up with the high quality of water, because they don't need any such small quantity of ions to be there in order to produce the product. So again, this plays a major role in assessing the climate change, energy as well as water consumption during the product manufacture. So this also this comes in a handy thing, that what would be the impact by having those onto the field. So these are this is one such example article that has been done with respect to LC of glass versus PET bottles. So this is one such very debatable thing, whether glass is superior over the PET bottle. So both has its own advantages and disadvantages. Glass can be, there is one section of the society claims that gas can be used any number of times, but the weight of the bottle for carrying 5 liters of water bottle with glass as well as 5 liters of plastic performs the other one, that is the clear one, the glass. So again, there is a debate that keeps going, and then but still, this is one such study where they have looked into the manufacturing of glass as well as PET. So with respect to this, blue dot is nothing but the system boundary. So this is one such terminology. Kindly have a look. So what needs to be done, or what are our goals? So what needs to be accounted for is one such big thing. Whether are we going for really raw material extraction? In some of the case studies, in some of the studies, they would have excluded the raw material extraction. So with the transportation, in which how whether it comes from continent to continent or state to state or through air, so all these things needs to be accounted for. And then what is the quantity of energy that goes in for manufacturing of one bottle of say 750 ml? So what would be the volume, or otherwise what would be the material that requires for manufacturing 750 ml of bottle? At the same thing, what would be the quantity of energy, or otherwise quantity of material as well as energy that goes in for 750 ml of PET bottle? So normally 750 ml is not mostly in the beverage industries, they go for 750 ml. For water bottles, you can go for 500 ml PET bottle versus glass bottle. So these are nothing but the system boundaries, what needs to be taken. And then whatever the arrow marks is nothing but the inputs on the left hand side for each of the boxes. So this blue color represents one such process inside the system boundary. Then there can be several processes which can act independently with respect to others. So, and then at last, out of this process, what would be the emission that comes out to the air, to the water, as well as to the soil? So those things needs to be accounted, and then which will be incorporated, and then that will be again used. So with respect to water, it can be again purified, and then it can be again reused for the process, but it depends upon what kind of process that you are taking down. So again, this is one such example, an examination of silver nanoparticles in socks using screening level life cycle assessment. So what would be the impact of having these silver nanoparticles onto a socks? So how the socks is being manufactured. So I just visualize it. The socks needs cotton, and then cotton needs to be transported, and then again it needs to be made as a manufactured as a socks. Again, washing, dyeing, all the things will be there. And then once the socks is being manufactured, then it needs to be coated with silver nanoparticle. What is the material that is required for silver nanoparticle? All will stay within the system boundary, and then the emissions as well as the energy that goes in for this process will be accounted and then analyzed for its impact onto the environment. So moving on, this is one of our study where a different kind of nanoparticle was used, which can be used for other purposes, and then a life cycle assessment was done. So of different, different shapes of nanoparticles, because of its difference in the process, the energy that requires, the quantity that it goes in for the product to be manufactured. So this was one such study that was out, and then in the study, there were 3 different morphologies, or the shape are given: disc, solid, and then as well as PS was made, I feel. And then it was analyzed, and then it was compared, which is having its own share impact onto the environment. And in most of the cases, energy dominates, and followed by raw materials and then the water that is being used. And then if you move on to what is the pathway, if we keep moving from the coal-fired, otherwise the energy that is derived from the coal-fired power plants to solar panels, the energy that we get from there. So how does the impact varies, and then what is the reduction in impact? But again, the solar panel comes with specific cost of impact onto the environment. Whether are you considering those, or that is being kept out of the system boundaries, one thing that you need to be well aware before. So the common platforms or the softwares that are available in commercial market, as per IS, which follows the 4 steps, it is nothing but OpenLCA. That is a freely available software. But again, the database is nothing but the input. See, I will come back to that in the later slides. And then SEMA Pro business version, SEMA Pro educational version. Again, SEMA Pro educational version is available free, but at the same time, there are not much of data sets. We have tried a couple of days back, but still we could not able to get the things that we needed. So Gabi Professional as well as Gabi Educational freely available. You can just have a look, and then you can just download it, and then you can, after this session, you can just download it, and then you can have a look at how the software looks, and then how does the interface, and then what are the parameters that can be given for the product that you're looking for. And these are commonly available LCA tools as per IS 10 14040 and 44. Among these, SEMA Pro and Gabi has been used extensively by most of the people across the world. So these two have good quantity, or otherwise the number of data that they provide. See, assume that what do you mean by data, or otherwise they in LCA terms it is meant as inventory data. So assume that what will be if you consume 1 watt of electricity or 1 kilowatt of electricity per hour, what would be the impact onto the environment? So those they might have calculated. They have calculated, and then they have fed into the system. So obviously, when you use, say, assume that for incineration, you use 500 degrees Celsius, or you use 180 kilowatts. So obviously, you will be able to arrive at what would be the impact onto the environment. So these kind of, there are around 2,400 data sets of different varieties, and then different sectors are available with these two platforms, and then so they are these two dominate the LCA studies across the world. So most of the studies that have been taken into considerations are mainly derived from or analyzed by these two softwares. So when it comes to comparison between these two softwares, it is not of much variations of less than 10% can be claimed as a variance, or otherwise the difference that you can able to arrive at. Just a minute. So with respect to the life cycle stages, so these are the 4 stages. So again, this has been again made it into different things. So one is the goal and scope. What is your goal? How are you going to do that? Is one such thing that you need to look for. And then data collection. So where do you collect the data from? That can be said as inventory data. So what are the material or the quantity that is required to assess the product? So that is one such thing. Modeling using a software, and then calculate the analysis, or otherwise they calculate the impact that has onto the environment. And then have once more you can have a quality check if you want to play with any of the parameters. Say, assume the transportation, if you move on from road transport to rail, what is the impact? And then if you in the road itself, you can again still choose different tracks of which has different Bharat stage standards. So assume that if it's Bharat stage 4, Bharat stage 6, what is the impact, or otherwise what is the change that is being applied onto the impact? And then again you can run the analysis so that you will be able to analyze the impact categories, and then you can able to compare, and the strategies that you can move on to reduce the impact onto the environment. And then finally the interpretation, so on what is the impact onto towards the environment. When it comes to goal and scope, one such thing that it needs to be kept in mind is the system boundary, which is already used, and then the unit that we need to we'd be using with respect to a product, be it the product. Nobody says that it is 1 bottle. So when it comes to 1 bottle, most of the studies they would have said that what is the volume of that bottle. So mostly 750 ml or 1 liter of bottle. Again, or otherwise 1 single pen or 1 paper clip or 1 coffee mug, which Professor Dubey was explaining. And then it is not only for a product, but it can be also used for a wastewater treatment system, and then how it performs, and what will be the impact, and then what it comes and when it goes out. So all these things are the basic steps, and then I will be taking you. So here we will be looking into the Gabi as one such software, and then this is how the database looks. So it has, you can save some of the project, and then balances, plans, you can make different plans, and then processes, you can pick up the processes, be it the steel industry or aluminum industry or PET bottle industry. So you can check or choose each of those items which are being kept as an inventory data. And then interpretation, you can interpret the results. Flows, you can connect between 2 different flows or 2 different inventory data sets, and then you can connect them, and then you can arrive at the product. The quantities, what is the quantity? If you want to create a dummy process, again, You can add it whether what is the quantity or what is the volume, and then global parameters, the impact parameters, the unit in which you wanted to have a look, and then user and context. That is of not much of use. And then flows in Gabi. Flows are nothing but if you want to connect two different processes, flows are being used. Flows are used to create inventories. They could represent the mass, the energy, as well as the cost. So assume that if you want to manufacture a product, then how much amount of energy that goes in. So if you assume that you are transporting a product or otherwise the raw material from one place to point A to point B. So if it is the distance is 100 kilometers, what would be the load that would be carried? What would be the energy that is being consumed? So all these comes under the inventory. So elementary flows are nothing but described interactions between product system and the environment. So again, resources we consume and then the emissions that because of that. So again, the resources is nothing but diesel that we consume and then the emission that is being let out to the environment. Intermediary flows, interaction within the product system. So between one process to the other. So between the life stages. So that we call it as intermediary flow. Flow in LCA do not provide any environmental upstream information. They simply quantify the input and output. So mostly they don't provide any information prior to that. But again, if they provide, once the inputs have been given, they provide the data aftermath of that. So this is nothing but the process flow diagram. So again, system environment or system boundary is what within that you are going to look into deeply. So that is one such thing. So other systems, again, whether if you are whether you are able to consider that or not to consider that, it is in your hand. And then again, elementary flows, and then as well as the elementary flows are flows that enter the technosphere, that is the environment, directly from the nature. So those you can find in the resources. So that is what is the resources that you take in, and flows that exist from the technosphere. So one, what it enters and then what it goes out. That's what I said, that diesel as well as what is the emission that comes out from the product, otherwise the system. Into the nature. So it can be the impact can be onto the air, the impact can be onto the soil, the impact can be onto the water. So so when it comes to non-elementary flows, so those are flows that move only within the technosphere, within the environment. They are not entering directly from the natural world and do not exit the technosphere to the natural world. So again, as I mentioned, within those two processes that it exists. So once you enter, so as I mentioned that, so here once you this is how the Gabi looks, and then these are the projects. And then if you want to save any of the projects, if you double click that projects, you'll be having a series set of projects what you have saved. Otherwise, if you want to create a new one, you can create a new one inside that project. If you want to have a PET bottle assessment as a project, you can save as a project, and then in that you can start looking the processes, what kind of processes that you need to give into. Sorry. So processes, what kind of processes that you would be picking up and then interconnecting and then assessing it. Processes are organized in a folder hierarchy, what kind of goods that you are going to make, and you can pick it up from that. So if you choose the energy as one such thing, say, assume that if you could able to see that electricity is nothing but EU is nothing but the European Union, electricity grid mix. So obviously the energy that you get from the grid. So normally in India also, the most of the power is obtained from the grid. So very rarely the people have their windmills in their farms and then they utilize that. Mostly the energy is being taken up from the grid and then it is being analyzed. So this can be picked up, or otherwise with respect to India, in the software it is available with respect to northern grid, southern grid, eastern grid, western grid. So whether you want to pick up the energy from that, or it can be from the solar, or it can be from the power generated from nuclear power plants. But still India, with respect to India, the power that is being utilized is mainly from coal-fired power plants. Around 63% or close to 63% is being derived from that. Otherwise 58 to 63 is the percentage. So with respect to process types, there are different processes and its type. So here One such thing, as I have mentioned, that EU is nothing but the European Union. If you search in India, that Indian data sets will be there. This is what we call it as inventory items. So already those data are already being there. So again, AGG is nothing but the aggregated data. So in this, you can see the region, name and source of process, last change, and then the process type. When was it last changed, and then what is the source and everything. So the type of processes include USO stands for unit processes, that is single operation. It will do only one. Aggregated indicates a combined thing, two to three different processes that we call it as aggregate. P aggregate is nothing but partially aggregated, indicates a partly terminated system, which I will be explaining. So with respect to USO, USO is nothing but unit process. This is one single processes which is represented as USO. It is nothing but referred to as a unit process or gate-to-gate process. So it is being very unique, so that it is for a specific what is it? Within the community. This process type contains only the data for any specific process step, and no LCA data is there. So it is very specific to that process. So we go for USO. With respect to, there is another one type, UBBB, where it is a black box model. So you don't know what goes in, what comes out. But still, if you are not sure what is the percentage of material that goes in and then goes out, you can still choose UBB. UBB represents black box. So where a multifunctional process happens within the plant. So inside the boiler, if you have two three reactions happening and then still not sure how much to quantify, then you can classify it as UBB. This type of processes may represent a group of processes, so which can happen within one system rather than a single step process. So here in USO, it is a single step process, but in UBB, it is a combination of process, and then which you don't still really make out of it one single process. So if you take for an example, so if you want to know how much the product chain of a computer keyboard key, so there are different keys and then how it is being manufactured. So all we can club it as UBB rather than having for each and every single component. So AGG represents for the aggregated. So in this, mostly the LCA indicates an LCA result. LCA is nothing but life cycle inventory result, contains the entire life cycle data of that part or a product for the complete life cycle of the product system. So this mostly refers to cradle to gate process rather than gate to gate, which is nothing but USO. With respect to partly aggregated system, so again, sorry, just I will go back. Yeah, I was here. With respect to the partly aggregated system, so where you will be having half the information, you will not be having the full quantity of information, contains all the LCA data for the processes except one or more product flow. So again, as like the black box model, if you don't have any such flow that is to be connected for the process, you can still categorize them as partly aggregated process. For this, most of the times we would be going for USO or UBB or otherwise an aggregated process rather than P aggregated. So if you could able to look at it, once you choose any of the process, so assume that we have picked from here, it has electricity from grid. So there are different nations. So in this case, we have picked up D. D stands for Denmark, and then electricity grid. And then this is an aggregated. So for one system, so as I have mentioned that aggregated is nothing but it contains the impact life cycle inventory results for the entire process. So for the electricity at grid, it has the result. AGG is nothing but the aggregated one. It has the results of the whole inventory. So what goes in, what comes out. So this is the input, and then this is the output. With respect to X, here, if you look at, there is only one mark, whereas here there is no such mark. One such mark is nothing but the tracked flows. We will be coming later on with respect to the track flows in the coming slide, why we need to track the flows. So if you track these flows, so these are, you can say in a simple terms, these are the important flows that you need to keep citing it for. So or otherwise the most importance has been given to these flows. So tracks flow include valuable substance and energy flows that can be used in another process. A tracked output flow can be connected with the tracked input flow of the following process in the same process flow chain. A connection between the plan and processes by track flow is also possible. So with respect to plan A, if you have 2-3 plans, so assume that plan A with respect to the transportation of a product is by road, and then for plan B it is through rail. So you can have a similar kind of track flows. So tracking this flow will make sure that this flow will remain in the technosphere within the environment and represent the track flow and then the waste flow of that particular product, or otherwise the flow or the inventory data that you have picked up. This also gives an upper hand for you to connect flow with the same plan or with the other processes. So it is a bit tricky, but you can just understand that by tracking the flow, you will be able to get its whole impact onto the system. So otherwise, you can consider that the important flows are being kept under the track. So plans, till now we have seen the processes. What are the types of processes that are there? Now we go on with respect to the plans in garden. So with respect to plans, so you can make different plans out of it. So one such thing, as I have mentioned, that for a product, you can make a plan with respect to point A to point B, where the material is transported by road, whereas for plan, the other plan, it can be made it as through rail, and then still you can able to compare. So plans, again, these are nothing but the processes which are connected to a process, a big process that happens, and then which are the inventory is connected by a flow, and then at last all the flows are connected, and then you come up with you analyze and then come up with the results. So if you don't have any such a single value or the inventory data, then you go for dummy process. So dummy process is nothing but if you look for any component, say antimony trioxide, when it comes for PET bottle manufacturing, if you don't have that value or the inventory data in the software, so even the software doesn't have those inventory data into it. So what can be done? It can be done with respect to a small kind of dummy process, and then you can give the input and then you can quantify them, but still you will not be able to, the software will not be able to consider them, but still you can incorporate that as a process, but it will not have its value over onto when you analyze for the chip. So this I think I think you will be able to understand with respect to the image itself. So this is nothing but the system boundary, and then a plan consists of identified process. So there are different processes that are connected by the flows. One process is connected to the other process by a flow. That's it. And then with respect to a plastic cup, so that's what 1 kg of plastic cup. So plastic cups are produced in Germany from granulate by injection molding with the use of electricity and compressed air. So here for manufacturing plastic cup, you need to have electricity, compressed air, as well as granulate, PET granulate. PET granulate is nothing but a sphere. So normally plastics will not come like this, and then they have a sphere, and then they do molding of whatever the molding size or shape that you have, it will be there. For a tonic bottle, the molding will be different. The sphere, otherwise the granulate will be of different. Mostly it will be of sphere in size, quite nature, and then they will be adding pigment to it so that it gives color. So to produce 1 kg of plastic cup, that's what, as I have mentioned, that it will be if you want to make that, you can still measure. If you want to correlate with respect to the one number of plastic cup, you can just check what would be the weight of it, and then you can correlate with respect to that. 1 kg of plastic cup product by injection molding, 1.05 kilogram of PET granulate is required. Otherwise, the plastic granulate is required. The type of plastic granulate is PP, that is nothing but a type of plastic. PP, polypropylene, polystyrene, polyethylene terephthalate, all those are things. PVC is also one such thing. Energy consumption for the process is 6 megajoules of electricity. So electricity can be from the grid or from the natural resources such as solar or water, and 5 cubic meter of compressed air per kg of product. So 5 cubic meter cube of air is required for 1 kg of plastic cup to be produced. 0.05 kg of granulate ends up as a waste out of this and goes to the waste incineration. Once made, the cups are transported by truck for 100 kilometers. When it comes to truck, so again 100 kilometer, what is the standard that it follows, whether it is Bharat stage 4 or Euro standard, you can say it as Euro standard 4 or 5 or 6, you can pick it. So this is how the software looks or the interface looks. And then once you click, so once you open the database, so assume that it is paperclip database or otherwise, you open this and then this starts loading, and then it will look like this. So automatically you go into this project. So if you don't have anything, you can create a new process. So in that, once the new process has been developed, then this is how the interface looks. So here you have the name of the material that is going, or otherwise the product that you are going to looking for, plastic cup production, and then you can just look it for USO or UGG or UBB or aggregated. So here the input and outputs are being classified separately. So as mentioned, the input is electricity, compressed air, PET granulate. So with respect, not PET granulate, PP granulate, polypropylene granulate. So those three are being given as input, and then the output would be plastic cups. So again, plastic cups followed by waste. The waste is being taken to incineration plant, so that waste incineration can be given. So one such thing with respect to the mass that you are referring, the mass balance needs to be perfect. And then as I have mentioned here, so all these are most important flows. So you give the importance to it. So if you want to have this waste incineration as important flow, you can click it, or otherwise you can leave that. And then as we are looking forward for 1 kilogram of plastic cup, so here we have clicked that plastic cup as the most important track flow. So this is how the process are being linked with the help of flows. So PP granulate followed by electricity as well as compressed air, and then this is how the flow is being connected to the product. Product here is nothing but the plastic cup, and then the waste that is being taken to the incineration plant. So once after this, here you can also say that the product that is being transported for a distance of 100 kilometers, so that needs to be also taken into account. So when you have a global truck, so again truck which is of unit USO for single operation, so that is being, so the distance here is mentioned as 100. So here you can able to change that kilometer based upon that, all the share of carbon dioxide as well as the other component that gets from the exhaust will also be modified. So this is how the results look, and then this is how the plant looks. The process are being connected, and then here there is a small graph kind of symbol where if you click that, then the results will be calculated by the software, and then you will be able to have this kind of backdrop where you will be having global warming potential for 100 years. AP is nothing but the acidification potential, eutrophication potential, ozone depleting substances, adiabatic depletion products, and then fossil fuel, toxicity related parameters, and then all the land use, and then the impact onto the environment will also be given. So with respect to, as this gives all the total say 12 parameters or 11 parameters. So if you look at it, it will be like you will be able to arrive at the total impact of all the processes. Or if you are more interested toward each and every single process, then it will be having its own share. The total will be broken up, and then it will be communicated. So, the mostly with respect to the impact categories, it will be like global warming potential, stratospheric ozone depletion, ozone formation, terrestrial acidification, particulate matter formation will be used or otherwise used to communicate. With respect to that, the parameters can be clubbed, and then it can be also communicated in layman terms. Everyone will not be able to understand the technical terminology, and then this can be clubbed, and then it can be communicated still. So with this, I will stop. And then we can take a break of now the time is just a minute. Stop share. Now the time is 2:55, and then we can rejoin by 3:10. So I need to move on to a specific place so that we can have, I can take you forward to the software, and then I will show you uh, how to link the process, and then how to calculate, and then how the results will be generated. So if that is the case, if you have any questions, you can drop down in chat box. Okay, it's all right. So we can meet at 3:10, or otherwise we can meet at 3:15, so that I will be taking you, the link will be remaining the same, and then I will be taking you through the process of GAR for calculating the impact of a specific product using GAR. So thank you all. So we will rejoin at 3:15 exactly. Jagdish? Yeah, am I audible? Am I audible? Okay, fine. Jagdish, am I audible? Now, could you just check that? Am I audible? Yeah, okay, fine. I hope it's audible to all. Yeah. Can anyone confirm? Am I audible? Yeah. Am I audible? Am I audible? Can you anyone confirm? Okay. Thank you. So I think we can move on with respect to the. We'll share the screen. I think now the screen is visible, right? Um, I think yes. So this is how the software looks, and then as I have mentioned that. So 1 minute. So once this is the professional version that we have, and once you open it, and then it will look like this. So when I mentioned that in the PPT, so you will be having the projects. So under this professional database, you will be having different products, and then you can have different modules, the balances, and then you can create your own plan. So there can be n number of plans. Under this, you can create different plans. And then one such plan, we have used our different plans for different studies. So in this, we will be looking at the paper plastic cup production. So with respect to that, if you double click it, so this is what I was mentioning. So this is nothing but, okay, the screen visible for everyone. I think screen sharing, I'm not able to see. So am I audible first of all? Yeah, okay, I'm audible. So I will again share the screen. Screen share. Share. Okay, you are in a position to see the screen? Sabarinathan? Okay. Now it's fine. Okay, fine. Good, 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 good. So yeah, so this is how the professional version looks once you open that. So just let me go. Manager. Okay. So DB manager is nothing but the database manager, and then here as projected. So here we have different database sets or different projects that we can create, And then inside that, we can create different plans. Once you open it, there will be different plans coming in, and different processes. Which processes that are you going to? Is it from the agricultural field, auxiliary process, benefiction, or construction industry? Once you click construction industry, you will be having different materials, whether it is air conditioning, electro, or coatings. What are the types of exterior paints, interior paints, construction materials? What kind of material that you are going to use? But if your product system or the material that you are going to look in for is of cement industry, or else you can pick it for different processes, and then you can make a plan, and then you can be able to analyze the system. So end of life treatment, and then energy conversion. So what is the electricity supply? What is the fuel production? Whether it is crude oil mix or lignite mix, everything you can able to pick it up from the software. So this is nothing but the inventory data. So mostly the inventory data set is nothing but the data that you are going to get it from here. So assume that, okay, accessories, if you click that, then it will again open it up. So as of now, I am not going to do that. And then interpretation, what kind of interpretation, normalization you want to do, or weighting. So let us not go into that. And then the flows, what kind of flows, emission to agricultural soil or emission to air, those things, again, it will be part of the plan as well. So let us not go into that. So once you have created the plan, so assume that you can create a plan, and then one such plan has been created. If you want to create a new plan, again, you can create a new and then start doing it one by one. So this plan has already been made. So this plan denotes this kind of symbol, and then this is nothing but plastic cup production, which is the one that we were discussing the session before. So once you do that, so as we had seen in that PPT, that we need for 1 kg of plastic cup that needs to be produced, you need to have polypropylene granulate, so 1.05 kilograms, and then electricity from a different mix, and then compressed air, and then at last you get a product of 2 kilos. And then so there it was 1.05. Here we have given it as for 2 kilos. Then 2 kilograms would be the weight of plastic cups that would be getting, and then 0.1 would be the waste that would be sent for waste incineration. So here, if you want to type any such thing, so in these processes, one such thing that you need to look into is, this is nothing but the flow. So if you delete it, and then so align it, and then from this part, you need to collect this process, and then these are the two processes. So this is nothing, injection molding, it will be done for different products, but we can create one such product as also. So here, if you want to create as such, you can create a new process. It can be, you can decide whether it is manufacturing of beverages. Say, assume that it is manufacture of beverages, you can club it under that, or it is under an agricultural product, you can keep it under the agricultural thing, or benefaction or protection. So assume that it is an assembly product, so you can just keep it under this category, or otherwise is it an electronic item, still you can classify under that. So assume that this is one such thing that has manufacturing, already we have seen that. So it can be manufacture of beverages or otherwise food products. You can categorize under manufacturing itself. If you are not very pretty sure about it, you can keep that. And then otherwise you can, if you produce anything, so again it can come under material production. What kind of material? Is it a packaging? Okay, yeah, it is really a packaging material. Again, you can click the packaging, and then you can save this process. And then see, assume that I create one such thing, and otherwise the plastic production as such. So assume that I keep it here, and then say okay. So automatically a new process will be available here. So the new processes can be named. So it can be, say, assume that it can be named as injection molding. So you can type so injection molding as one such process. And then from here, you can able to click here as we have said as unit process, one such single process, or otherwise unit black box aggregated. So one such thing is that electricity that we have already looked, a combination of different processes, and then which we don't have control, and partly terminated, and then avoided product system. So either it would be there in unit single. So let us give it as single process, and then either you can get any name. So assume that Asia is there, you can click Asia. So Asia is the place where you are looking forward for injection molding, and then this is a single unit process. So source, let us not touch into that, and then you are bound to give the input force whenever you want to give. So before that, you can save, or otherwise say, let me say that injection molding 1. You can save this. So there is no project active. You would like to continue, say yes. And once you do that, so assume that you need to keep the flows that needs to go on. So what is the input that you need for this injection molding? So there are 3 things that you need for the injection molding. So one such thing is that, so let me say it as compressed air. So once you type compressed air, so you can double click it, otherwise you don't have it. So let us research it. So I have done a spelling mistake, so it doesn't show. So compressed air. So once you click that, once you do that, enter, so you will be having all these data sets. So compressed air, 10 bar efficiency, what is the valuable source, and then so there are different types of compressed air: 6 bar, 7 bar, 14 bar, 10 bar, and then here if you want to type with respect to the nation or name, it can get according to the own. So here we can pick any one. So assume that, let us take it as average efficiency or high efficiency. Okay, let us take it as high efficiency. So a compressed air of 7 bar, high efficiency. So once you pick it up, what is the volume? So again, standard volume, the volume is 10 meter cube per kg, or otherwise say, assume that it is 10 meter cube. And then the next thing is that we need electricity. So once you click on electricity, so when you look at compressed gas, India dataset was not available. So in that case, not all the softwares will come with Indian datasets. So if Indian datasets are not available in the software, you can go for global available data, or otherwise the rest of the world. So I will give you an example. So here there are different names of electricity, or otherwise the electricity that is being produced from different products. So electricity from landfill gas, are you going to utilize that? Or electricity from waste incineration, are you going to pick that? Electricity from lignite, hydropower, coal gas, wind power, imported. And then there are different processes, or otherwise flows that you can pick up. Electricity from photovoltaic, the solar power. So or otherwise you can just look for IN, whether the data is available or not. HI. Yeah, IE is there, IT is there. So IN is not there. So you can go for IN stands for India. So IN dataset is not there. Or otherwise, say, assume that you go to the top and then you look for electricity grid mix. So here, let us type it as grid. So again, so there are different countries that produces high voltage electricity at grid, and then so here you have production mix as well as supply mix. You can guess the supply. So let us see whether we have it for India. So again, IN is not there. So for Indian dataset is not there. So let us assume that IT or IEV, let us pick it up. Otherwise, DEV, we will pick it up. Any country we can pick it up, as the Indian dataset is not there, but there will be slight variation. As the dataset is not there, we are picking up for other countries. Or otherwise, how electricity grid mix, let's say, okay. So here it has been mentioned as GLO. So again, global data value that comes out with it. So if you want to take high voltage for aluminum industry supply mix, or otherwise we will take it as GR high voltage. Otherwise, okay, let us take this. So what is the amount of electricity that goes in is nothing but 12 megajoule. So 12 megajoule, and then this we need to track the flow. And then last but not the least is polypropylene. So here you need to type the whole thing, poly, PRO. So okay, polypropylene, enter, and then waste. So here this polypropylene is also shown as waste for recovery. That is not the case that we are looking for. Polypropylene. So again, so okay, just a minute. So once you type polypropylene, there are polypropylene granulates, compound, polypropylene fibers or polypropylene as such as a material. So what are you going to pick it up? So here we are looking for polypropylene granulate. So this granulate is being used, and then what is the quantity that is being used? Say assume that 1.05. So 1.505 is the amount that goes in, and then at last we will be getting plastic cup. So here at the output, so again you can save the process. At the output, you can say it as plastic cup. So again, it is available as such. So what would be the quantity that you will be getting? So if you add one, if you give 1.05, then obviously you will getting 1 kilogram of plastic cup. And then with respect to waste generation, waste in, okay, you can just type waste incineration of biodegradable. No, so you can just type it as plastic waste. So this project, if you type plastic waste incineration, this is not available in the data set. So let us try with some other keywords. So let us see. Okay, so here we have waste incineration of plastics, nylon. So here they have given it as plastic waste incineration of plastics, that is PE, PP, PS, PB. Again, so you can pick it up. So let me pick this, and then what is the value? That is nothing but 0.05. So you save this product, or otherwise the process. So now you need to search the same, otherwise you can elongate it. So now you need to add, or otherwise to connect the flows. So for that, you can, what you need is first here, you have given the input for this process. So this is one such single process. And then here it has been mentioned as 0. And then this is the crucial process. So if you down, just a minute, if you click it here, let us keep this product as fixed. So once you allow this process as fixed, so there will be a X mark that will be coming here. So that is one such thing. So if you don't give the, if you don't keep this as the fixer, so there will be different processes, but the system will not be able to know which is most significant. So in that sense, so we have kept the injection molding as a significant process, the most important one. And then here we are going with compressed air. So here, as mentioned, so once you have already given all the data, and then now here we have compressed air. Different EU is nothing but European Union. So as per nation, let us see. So the local content has 15 data sets. So this all the either European Union data set is there or global data set is there. So let us take compressed air of 7 bar. So I'm just double clicking it, or otherwise you can drag and drop here. So I'm closing this. So once this is of 7 bar, already we have made the process. So I'm connecting this. So one such thing that you keenly observe is that, so once you connect it, the compressed as well as compressed R, you can just give it and then it gets connected. So before connecting, there were 3 red color dots. So once it means that there are 3 processes that you need to connect for this system. And then one has been changed to black, and then the other 2 has been retained as red. So once you search for the other 2 things, so that is nothing but electricity grid. So here comes the different nations. So let us give a try whether electricity is available for Indian case. So yeah. So here we have electricity grid for production mix. So again, here we have, and then if you want to again see the processes, let us go into that. Again, that is nothing but the plant. So here you can just able to see at this icon. So that means that it is a plant. So let us not go for the processes, not for the plant. So if you go for India, India stands for IN. So yeah, here it is. Electricity grid mix, electricity mix of 1 kilowatt to 60 kilowatt, or let us say mix to consumer. We can pick any one, and then I am clicking this into the system. So here the next component comes out to be electricity grid mix. So I am connecting this. Kindly have a look into this thing such a way that Once I connect, the red color dot will turn into black in color. So I'm connecting it to the process, and then it is nothing but the electric power and then electricity high voltage, and then click that. So the electricity is being connected to this process, and then at last it turns to be dark black in color. So the next thing that it is left over is polypropylene. So once you search in the database, I think polypropylene is not there. I made a typo error. So here again, you can make it with respect to the nation. There are 12 data sets available. With respect to India, it is not available. So let us take the European data set. So polypropylene PP granulate. So this is available, and then this is close to what we require, and then we close the system. So let me connect this. So kindly observe that once I connect it, this will turn into black in color. So all the things that are there onto the left hand side has been connected, and then now we need to look for one such thing that is still red in color, right? So now we need to look for a product. So what is the product, or what is the product that we get out of this process? Is nothing but the plastic cup. So let me type it as a product. So here again, with respect to nation, these are the different processes that have been created. And if you go down, let me see that for global, we have a product. So this is nothing but a global product. We take this and then close it out. So here, so I can take this from here. This is, I have connected it here. Again, the question comes whether waste incineration is a product of incineration, inject molding, or plastic cup is a product. So here we connect these two and then click OK. So 1.05 goes as a plastic cup, and then at last, still the mass balance is not done. And then, so one such thing is waste incineration. So again, waste incineration. So what is the waste that we are dealing? It is about polypropylene. So you can look for the PET waste, or otherwise we can just say it as PP. So let us search, and then let me see. Yeah, polypropylene in waste, and then there are only two countries. One is DE and then EU. So let me take it as European Union and then place it here. So one such thing that you can keenly look is that, so as the product is getting connected, so there is no second dot. So then you can say that whether I need to connect it or not, but still you can connect it and then see whether it connects or not. So as we have given two entries, and then if you could able to relocate one minute. So here, if you go to database settings, so here I have not made it as tracked system. So let me make it as tracked system and then save it. So here you will be having two dots. So if I make it as a single, if I don't track it, or otherwise I make it less priority. So if I save it, then there will not be any dot. So I am just connecting it. So major of the chunk goes for the plastic, and then so here waste incineration and incineration good for waste disposal, and then it has been connected. So this is how you connect the flows between the processes, and then keep one single process as constant. Then all the things will be revolving around this injection molding. So I hope it is clear. I think I have explained. Am I fast, or is it clear for the audience? I hope it is clear, I feel. So I will move on. Okay. So once this is done, as there are two processes, so I will just delete this one. So I'm saving this, and then for analyzing the results, so what I will do is that click this arrow mark, so calculate results. So you can either press Control B, or else do a simple click, and then it will keep calculating what would be the impact of this onto the environment. So here, if I make it and then make it display 1, so this is nothing but the global warming potential. So with respect to EU propylene in waste incineration plant, it contributes the 0.05 kilogram contributes to 0.313 kilogram of carbon dioxide equivalent to the atmosphere. And then the propylene, the raw material that goes in for plastic cup dominates the impact onto the global warming potential, followed by the electricity. So here it is 3.41, followed by the electricity that goes in for the production of plastic cup. So which dominates what is the question now. So one such thing is that the raw material dominates the electricity. So this is the simple thing that we have looked into, but still it will, for a simple product or for a product, it will not be as simple as this. Because here we have not taken transport into consideration through rail or road or sea. That is one such thing. The reuse pattern of this has not been into consideration. So all these things, if it gets into the process and then the flows are connected, then you will be having different processes and then share onto the global warming potential. So this is how the results look. So I will just, what I will do is that I will again go back here and then I will add transport as one such thing. So let me give you another purview. So I'm saying that the material gets transported. So let me see whether it is the global Indian data set is not there. So I'm picking a cargo truck. Let us see it is the material gets traveled through road. So it is 7 to 5, 3.3 payload, and then there is no European standard. Okay, let me take this as one such transport material. So I delete this flow and then I connect it to transport. So there is no, okay, sorry, I have picked up the wrong thing. Okay. So I think I will pick up the just a minute. So what you can do is that you can either give it as transport or as a truck. So here I have given it as truck. So now you have different plants and then the processes. So let us look with respect to the country wise. So let me see with respect to country wise, we don't have Indian data sets, but global and US data set is there. Let me pick a global data set and we can try it out. So let me see whether the European Euro 3 standard is there, as I have mentioned, and Euro 2 standard is there, and let us pick Euro 6 standard. So I will pick this Euro 6 standard and then I will connect this as the cargo. So now the question asks, while connecting the flow, so whether this plastic is a cargo or not. Yes, it's a cargo. So obviously you connect it to the flow. So for running this, you need to have diesel into picture. So again, you type diesel. Again, you can take a diesel mix from refinery from EU to 28, and then you can add this as the fuel for the road. So now this has been connected, and then if you look at the database settings, sorry, otherwise you go here and then local settings. So here the distance has been given as 100. So either you can make it as 100, 10 or 1000 or 10,000, or otherwise 750. So let us make it as 740 kilometers is the distance that is being traveled. So once you close it and then yes, so this will be taken into consideration. Now if you analyze the results, say save, yes. If you analyze the results, then okay, let me showcase you. So there comes the truck representation towards the global warming potential. So though the truck travels 750 kilometers, but still the impact by the material onto the environment is very huge when compared to the other raw materials. So this is one such thing that you can play off. And then apart from these things, so let me go again, the plasticity project. So apart from this, again, the other things can be, the product can be again taken forward for other use. So whether the product, or otherwise, if there is any waste that is being generated here, what kind of waste, whether it can be again recirculated back into the system is one such question. In that case, again, the plan or otherwise the flow will be modified. So in that sense, this is how the life cycle assessment or otherwise the analysis is being done, and then the impact categories, or otherwise the results, once the results are out, then we take up the results and then we analyze for each and everything. So again, with, okay, 1 minute, I will go with this itself. Yeah, with respect to the parameters that we are interested in, whether it is global warming potential or acidification potential. So let me click acidification potential one by one. I will show this. So with respect to acidification potential, which has the major say? So for this, the electricity has a major impact than the raw material. For global warming potential, the plastic material itself had a greater impact, but for acidification potential, if the other one had the greater say. So again, eutrophication potential, if you go ahead, then again, eutrophication potential, the the material of polypropylene itself had a greater impact onto the environment than the thing. So with respect to these two, then you need to again look why electricity has a greater impact on acidification potential rather than the eutrophication potential. Electricity for India, again, it is carbon-based or otherwise coal-based fire power plants, coal-based plants, so that it consumes more amount of coal. So once you burn up the coal, again, you end up with more and more amount of greenhouse gases, be it the SOx and NOx, so that it can correlate with respect to the acidification potential that is being given as the unit of kilogram of SOx equivalent. Whereas for eutrophication potential, it is kilogram of phosphate equivalent. When it comes to these two, raw material as well as the electricity, so the coal doesn't contribute much towards the eutrophication of lakes or other things. So this is one such thing. So let us go with ozone depleting layer depletion. So again, so it is on the top and then it is not on the surface that we live in. So again, which dominates? It's polypropylene granulate that dominates the ozone layer depletion rather than the raw material itself. So if you go with one after the other, so then you will be able to arrive at the impact of each parameter onto the system. So again, in this, several permutation combinations, or otherwise the changes in values, or how the system can be again made with these results, how we can make the system sustainable can also be put forward by having the scenario analysis. So as of now, we will not be carrying out the scenario analysis, but still this is one such step towards calculating the footprint of any product onto the environment. So if you have any questions, then I will take it up. With this, I will stop here. If there are any questions, kindly let me know. Yeah. Okay, if there are no queries, then we will wind up for today's session, and we will meet tomorrow again at 9 o'clock in the morning, so that Professor Lok will be handling his lecture. So, and then if you have any queries, or otherwise I ask you, or I prefer you to install the trial version, which is available for everyone, and then can incorporate any simple for a product, or you can check what are the flows or the process that is available with the trial system, and then you can do a hands-on session. And then tomorrow afternoon, I have a lecture routine 2:30 to 3:30. And then if you could be able to get back to me, then it would be really happy so that I can able to help you out in overcoming any of the difficulties that you have faced. So thanks a lot. So let's meet tomorrow at 8:55 a.m. for Professor Lok's session. Thank you all.